Hello and welcome to binary long division. We'll be taking the same approach to long division as would be used in deanery and taught in primary schools at Key Stage 2. Might be a bit easier, as we actually only have to deal with the zeros and ones. For this we will assume a basic knowledge of binary, that is to say you should know the numbers from 0 to 15 in binary, and you should be able to convert any other binary number into deanery. I'll outline 3 examples with increasing difficulty, and then I'll present you with 9 questions for you to try yourself and the answers. Let's get started. So, example 1. Let's start with 2 binary numbers and what these numbers are. If I look at the weightings for each number, we can see that the number on the left has a value of 3. It's got a 1 and a 2. And the other columns, we have 32, we have 8, and we have 2. That's 42. So what we're looking at is a calculation of 42 divided by 3. How we do this is we start with the number 3, 1, 1 on the left hand side, and we compare it with the first value and say how many of these fit into that. How many 1 1s, how many of the value 3 fit into the value of 1? Doesn't fit, so we put a 0. Does it fit into this value? 1, 0, which is 2. 3 does not fit into 2, so 0. Does it fit into this number here, which is 5? Yes, 3 fits into 5, so we can put a 1 on the top line. And that's our first set. The first time we've been able to fit it in. We now need to know, well, what's the difference of 3 and 5? We need to take away our 3 from the 5 to equal 2 in binary. We could compare our 3 with the 2 and say, does it fit? But of course this is the remainder of a previous calculation, so it should never fit. So we now need to move the next digit down, and now we can look at this number here, which is the number 4, and say, does the number 3 fit into number 4? Yes, it does. We can put a 1 on the top line, and again we can now look to find the difference between 4 and 3 by taking 3 off. Difference is 1, and now again we can't compare 3 with 1 because that's our remainder already, so we now need to move the next digit down. And does 3 fit into the number 3? Yes, it does, once, and there are no remainders. If we take 3 off that, the remainder is 0. We can carry the next digit down, and that is also 0. So 3 does not fit into 0, 0 on top. We now have our completed calculation and our answer on the top line. Our answer is 1110. Our remainder is 0, 0, so we've got no remainder. 1110 is the number 14 in deanery. Example 2. We're now looking at 2 different numbers. We've got a 4 and a 1 on the left hand side, so that is the number 5. We've got a 32, a 16, a 4 and a 1, giving us 53. So we're looking at 53 divided by 5. We're looking at, does our 101, our value of 5, does it fit into the value of 1? No. Does it fit into our value of 1, 1, which is 3? 5 doesn't go into 1, 1, so no. Move along again. 1, 1, 0, that's the number 6. Does 5 go into 6? Yes, it does, once. 1 goes on the top line, and then we need to know our difference, so we need to take 101 away from 6, giving us 1, the difference between 6 and 5. We're now looking at 101 again and saying, does that fit into this 1? No, obviously not. So we're going to carry our next digit down. It still doesn't fit into 3. Our next digit down. Again we've got the number 6. It does go in there, so a 1 goes on the top row for where it does fit in. This is a great thing about binary. It either fits in once or no times. you're not going to have, like with normal long division, where it can fit in 2, 3 or 4 times. Again, we now need to know the difference between 6 and 5, so we take 5 off and we result in 1. We then check that digit, carry the next digit down and say, does 5 fit into this new value of 3, 3 being 1, 1. 5 doesn't fit into 1, 1, but we can't move any extra digits down. So we put the 0 at the top, we've completed the calculation, we have our answer on the top row, 1, 0, 1, 0, and we have our remainder on the bottom. This time we do have a remainder of 1, 1. So our denary answer is 10 with a remainder of 3. You could look at this 3 and say, well, we were dividing by 5, so it's a remainder of 3 out of 5, and that is a 0.6. So you could say this is 10.6. Example 3. Bit of a longer number here. We've got 4, 2 and 1 in our left side. That's the number 7. And we've got 128, 16, 4 and 2, which is the number 150. So we're dividing 150 by 7. Does 7 fit into 1? No. Does it fit into 1, 0, which is 2? No. Does it fit into 1, 0, 0, which is the number of 4? No. Does 7 fit into 1, 0, 0, 1? This is the number 9. 7 does fit into 9, so we put 1 on the top. Then we need to know the difference between 9 and 7, so we take 7 off, and our answer is 2, so we can write in 1, 0. Checking this set, 7 won't fit in that, because it's our remainder, so we're going to pull the next digit down. Doesn't fit into that value, that's the value 4. Next digit down, again we've got the number 9. Does 7 go into 9? Yes it does. Put a 1 on the top, and then make our deduction to find our difference. We know the difference is 2, so you can write in 1, 0. This being the remainder, the value of 7, 1, 1, 1, does not fit into it, so we pull the next number down, 101. Doesn't fit into 101, so and we're going to have to pull the next digit down. 1, 0, 1, 0, the value of 10. Does 7 fit into 10? Yes it does. What's our remainder? 1, 1, because we know the remainder of 10 take away 7 is 3. Our answer is 1, 0, 1, 0, 1, with a remainder of 1, 1. That is the value of 21 with a remainder of 3. And once again, because we're looking at the remainder was 3 from the original division of 7, we could say it's 3 out of 7, or 0.43 rounded to 2 decimal places. So it's 21.43 in denary. There are our 3 examples. Here are some questions you could try yourself, and in 10 seconds this page will rotate onto the next slide, which has all the answers, so please pause this slide, complete these questions before moving on. And the answers. Thanks very much, and good luck.